All right, hello people watching this video. It was requested by Emma, I think, written on the board over there, that we do 13 and 14 together. So here we go, 13. Boys, you listening?
Yep.
13 is a what inside of a what?
Chain inside of a product.
It's a chain in a product. So the overlying rule is the product rule. So we're going to start with product rule. So F prime G plus G prime F. And I'm going to label everything out. But which of those parts is going to have the chain inside?
G prime.
G prime. G, like this is F and this is G. G is going to have a chain, right? All right, what's F prime?
One.
1. The derivative of x is going to be 1. Okay, the other part's going to stay the same. X to the 4th plus 9 to the 3rd. Again, like we'll get rid of the 1 eventually, but you know, you don't need to have it. Okay? All right, now G prime, this is where we get stuck. This is where we have to do the chain rule for this thing. Okay? 3 comes down in front. X to the 4th plus 9 stays. Now he is to the 2nd power. And then what's the derivative of the inside?
4x to the 3rd.
4x to the 3rd. Okay, times f, which is just the normal f. All right? I'm going to consolidate just a little bit of this stuff. Like here, I'm just going to leave that as x to the 4th plus 9 cubed because the 1 does nothing. All right, now things over here that I'm going to combine. Okay, I'm not going to touch this thing because I don't want to have to FOIL it out. Okay, but I can multiply 3 and 4x cubed and x. If I multiply all those together, what do you get?
12x to the 4th.
12x to the 4th, and then I have the other junk.
Yep.
And that's as far as I'm going to take it.
Yep.
Yep. Boom.
Okay.
Do you need the 12x to the 4th to be in the parentheses?
Can it be? I wrote it in parentheses.
You can have it in parentheses. It doesn't need to because it's only one term. But if you had multiple terms, like if this was 12 plus x to the 4th, you would need it in parentheses. Okay, but we don't for right now because he's only one term. He is a monomial. Okay, that was 13. 14, what is this? A what inside of a what?
A product or a
chain in a quotient.
A chain in a quotient. Okay, chain in quotient.
I was mad at you because you're like, okay, we're gonna go and label the rest of these. Then you ended the video. It took
We
like
didn't.
10 minutes.
We didn't. So, oh yeah, because I said, sorry Jake, you're on your own. My computer's gonna die. Chain in quotient. So we're gonna start with quotient, which is f prime g minus g prime f all over g squared. That's gonna go on the bottom. Okay. Which one of those pieces has the chain?
The 4x minus 9.
First one.
F prime, right? We got to worry about F prime, and that's going to be my chain. So this is going to be the chain part. Chain. And then the rest of it is like hunky-dory. It's fine. Okay, minus this and this and g squared. Oh, g squared will be x plus 7 squared. For some reason, I always do that one first. I don't know why. All right, F prime. Let's do the derivative. 5 parentheses. 4x minus 9 to the 4th power times 4. The derivative of the inside. 4. G just stays x plus 7 minus what's g prime?
1.
1. F is just that other stuff. 4x minus 9 to the 5th power. Okay, we're going to simplify just a little bit, but not a lot.
I did a lot though.
You did a lot though? Okay. Minus, I'm going to do this stuff. I'm going to leave this 4x minus 9 to the 5th power over here. The bottom's going to stay x plus 7 squared. Okay, I'm not going to FOIL any of this stuff out. Okay, but let's do this. 5 times 4 is 20. Let's go ahead and take 20 times x plus 7. What is 20 times x plus 7?
28 plus 140.
20x plus 140. I'm going to write it like that. And then I'm just going to leave my 4x minus 9 to the 5th power.
No way, Luke.
Or to the 4th, not to the 5th power, 4th power. Right? Okay, so 5 and 4 and x plus 7 all together is 20x plus 140. That shall be enough. We shall say that's it.
We do right in the middle of an example.
10.
That's not even a good circle. Bruh.
Okay, oh, you guys can't see. There you go. 10.
Can you grab that marker and see if you can make a perfect circle?
Why is it like that?
Make it perfect as you
That's just how I simplified it. If you did it differently, that's fine.
That took a lot of space.
I did take a lot of space. Number 10.
Oh, my leg.
Wait. He says wait.
That sucks.
Not
good.
Oh.
Why is it like this?
Okay.
No.
Ready?
No.
Jake, you're holding us back here.
I know.
I think we just need a review day.
No.
I don't get it. But
This
okay.
was our review day.
The stuff that we're doing today looks
They all
hard.
left me.
Why?
I don't. They're
You can
doing
go.
something.
Okay, number 10. Let's do this one real quick, and then we will be done. This is a what? A quotient. Quotient. F prime G minus G prime F all over G squared. I'm going to do G squared first. 3x to the fourth plus 5 to the second power.
How
Alright.
often would you say we use the chain rule?
Pretty often.
Damn it.
Yep, pretty often. Why? You don't like the chain?
I hate the chain.
Okay, F prime. What's F prime?
4x to the fifth.
No.
Or 16x to the fourth.
What?
20x to the fourth.
Kosher, why are there no questions like this on the ACT? There's none.
Because this is way beyond what you need to know for the ACT.
Yeah, but why?
I don't know.
Yeah,
Okay,
but
G
some-
prime. What's your G prime?
What?
12x to the
For
third.
some reason I still
12x to the third. That's it.
No, you don't. Just keep
4x to the fifth
What's your
plus
highest?
2x squared. Okay, how much farther did you go?
What were your
Hey, Jake.
subject breakdowns?
Math. What?
I times.
What'd you get in
Did you foil them out?
Marcus,
Yeah.
guess what
On
I
top
got?
and everything?
I feel.
Bleh.
No, you didn't.
Okay. All right, let's foil.
Nuh-uh.
Yes.
This is 60x to the eighth
You got, did you take
plus
it?
100x to the
Did you
fourth
actually take it?
Do you think I'm dumb?
plus 12x to the
So
fifth
you don't think I got a 32?
plus 20x.
Not your first try.
Okay, then the next one, negative goes, whoa, negative goes with the 12.
No, you haven't.
You boys, be
Have
quiet.
you even taken it yet?
Minus
You need to
48x
sign
to
up.
the eighth minus 24x to the fifth. Okay, so final answer. X to the eighth is the biggest. 60 minus 48 is 12x to the eighth power.
Oh, you simplify.
What?
12, so negative 12x to the fifth plus 100x to the fourth plus 20x. Is that correct?
I
Ha!
got that.
Rachel got that, so we're right.
I did. I can't
You
multiply
didn't
12
foil
with
the
four.
bottom though.
I don't care.
Wait.
You don't,
Okay, fine.
Wait.
What?
you don't need to do that.
Well, I apparently didn't know that because I did it on every single one.
Well, it's still right.
What if I foiled wrong?
Oh,
There you go.
it's not right.
Did you foil right?
Okay, I redid it in a different box. It's bad, but it's fine.
Okay, there you go. There it is. If you foil the bottom, there it is. Okay,
I'm still confused on 14 though.
good.
Oh.
On 14, child, I don't know what to tell you.
Go back down to this.
That's 14. I don't know.
Well, I had like I just had that, but without the 4x minus 9 to the 4th.
Like you didn't have this part?
Yeah, I didn't have that.
Because you forgot your G after you did your F prime. Which happens a lot because you, as soon as you do the chain roll, you're like, whew, that was a lot of work, and then you move right along and you forget the G.
If you say so.
Yep.
Yes.
For sure, that's what happened. I don't know, maybe not. Maybe you didn't do that. I don't know. Okay, good? All done? Is there any other questions?
No, I get
Okay. Just leave them somewhere and I'll pick them up or something. Okay?
Here you go, Rachel.
Go to 4-5. This is the stuff that we're doing today. This is the stuff that we're doing today.
Implicit in the rest.
Implicit. Implicit.
Oh, there's only 6 problems.
Woo! For homework?
It's probably
They
like
do take
parts
a
A through Z.
little bit of time. They take a little bit of time. Okay?
Yeah, I was expecting it to be a lot better.
All right, good?
Hey, hey, we need to have a talk. Are we your favorite class?
Stats is her favorite class.
Like,
She
not to
hates
teach,
stats.
but like, people in here. Are we your
Sure.
favorite?
Sure.
Maddie,
Whatever happens when you
no.
sleep at night. 4-5, implicit. Let's get to work on this. Here we go. We have been doing explicit differentiation.
Monday.
Well, it's been a
E-X-P-L-I-C-I-T. And the 4 things that we have been using to explicitly find the derivative. What?
Me and Kyle are gonna be gone Wednesday.
We don't care.
Thursday
We don't care.
and Friday.
We don't care.
Wednesday,
'Kay.
Thursday, what's Thursday, Friday?
Wednesday, Thursday, we have
FFA stuff.
FFA
Whatever.
and quiz bowl.
So you're gonna be gone.
Ah! On Thursday?
Yes.
Where?
Kennesaw.
Oh
We'll be back Thursday though. So
We'll be back. Oh yeah, we'll be back in this class. We'll just be gone for trade.
Okay, so then what about
Okay.
Friday?
Science fair thing.
Oh.
Ew, why
okay,
are you
isn't
going to
Austin going
that?
to that?
We're all gonna be
All right,
on this
moving on.
week.
Isn't it
Explicits.
voluntary?
Yeah, that's what I do not want to go to that.
Explicit.
Explicit. We have been finding the derivative explicitly the last couple sections. And these are the ways that we've been doing it. Quotient and chain rule.
You just hate
Okay,
yourself.
power product quotient chain. That's explicit differentiation. Differentiation is just finding the derivative. That's the word that they use. Differentiation is the process of finding the derivative. It sounds
on.
made up, but it's not.
Are
Okay?
you recording?
Yes, I am.
Oh, hi guys.
Okay, now we're going to find it implicitly. And here's the difference, okay? Implicit. 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 Implicit differentiation. Here we go. This is the difference, all right? Implicit form has x's and y's that are together on the same side. Like 2 different variables, right? An x and a y, okay? Eventually we'll end up doing this when we do story problems in section 4-6, the next section,
No.
where we have like circumference and area and
Oh,
radius
great.
and diameter and those things, right? Okay? That's implicit when we have x's and y's on the same side, all right? So here's the deal.
Are we going to solve with y and then find the derivative?
Just wait, we'll get to that.
We're
Okay,
playing
now,
inverse
this
derivative of
one-
mama.
in this problem, x, y equals 1, I have the option of solving it for y, right? And putting it in explicit form so that it looks like 1 over x. They've divided the x over, right? And then what I'm going to do is to take the derivative of this. I would move the x to the top to make it x to the negative 1 power, right? Then I would find the derivative. Now, here's the deal. We always try to label this guy right here. What's the derivative of y?
Y prime.
Y prime. Okay, they have different names for it, right? So y prime, sometimes they'll call it f prime of x, okay? They call it dy dx also, and this is the derivative, the wording that you use is the derivative of y with respect to x, right? With respect to x. The derivative of y with respect to x, that's what y prime is, okay? So we're saying the variable that we're taking the derivative of is x. So when we do y, it's dy dx, or y prime, okay? So these two are both interchangeable. They mean the same thing. Dy dx or y prime is what that is, right? Okay?
Well, wait,
Good?
If I put
Yes.
d of x over d of y, would that be derivative of x with respect to y?
Correct. Yep. Okay, so when they did that, the derivative of x to the negative 1 power, you move the negative 1 down in front, subtract 1 from the exponent, and this is what your derivative is. So our final answer would be that dy dx equals negative 1 over x squared, right? Like that's what he is. That's what our final answer would be, right? We took the derivative of x to the negative 1 power. That's what he would look like. That's what our final answer would look like, right?
Does that
Okay.
also mean that?
Now, that still is taking the derivative explicitly, right?
We're used to it.
We just moved it from implicit to explicit, right? Okay.
Yes.
Now, sometimes you will get a problem like this, where how do you solve for y? How do you get y by itself? Because there's 2 y's, and one's to the 3rd power, and one's just y. So how do we do that?
You go to
Yeah.
Jesus.
This is where you have to do the derivative implicitly. Okay? This is where you have to do the derivative implicitly. All right? Okay, so here's the deal. Implicit differentiation is when you have y's and x's on the same side. Here's how we do this, okay?
Does yx and dy over dx equal the same thing? Or mean the same thing?
What? Does y what?
Is yx the same thing as dy over dx?
No. Y prime is the same thing. Y prime is the same thing as dy dx. This means the derivative of y. These two both mean the derivative of y. Derivative of y. Those two things are the same thing, okay? All right, example 1.
I don't think it's
Okay.
that good, I've heard.
make sure you listen to how this notation is used, because you're gonna get like a problem and you're gonna be like, what the heck does this mean? Okay, right here, this is what they're asking you to do. This is the problem. All right, this is what they're asking you to do, and this part right here is asking the question. Take the derivative with respect to x. Take the derivative of this thing with respect to x. We'll talk about what the respect to means here in a minute. Okay, so this thing is just a command. This is commanding me. Take the derivative of this with respect to x. What's the derivative of x to the third power? 3x squared, right? The derivative of that is 3x squared, okay? This one is saying the same thing. Take the derivative with respect to x of this thing, okay? Right?
No.
Okay, now here's the difference. I'm going to go down to C. We're going to do C before we do B, okay? Here's what C looks like, all right? So I'm going to look at each piece individually. What is the derivative of x? 1, okay? Now, the derivative of 3y, here's where you're going to get stuck. You have to remember how this works. The derivative of 3y is 3, right? But with respect to x means like I'm taking the derivative with respect to x, meaning y is not my prime variable, right? So what's the derivative of y?
3.
What did we say the derivative of y was?
3.
No. What's the derivative of y? Y prime, or they call it dy dx. So when we take the derivative of y with respect to x, we have to note dy dx on the end there, right? Because the derivative of y is y prime,
Okay.
right?
So if that was like 3y squared, you'd put 6y though?
Yes, and then you'd have a dy dx on the end.
At the end of
At the end of it.
So
if we
at
Every
single
time-
you
Every single time you take the derivative of y, you need to put a dy dx on the end of it. So you are noting that that is what the derivative is with respect to x, because y is not my primary variable. X is.
It's really not that hard.
It's really not that hard then.
So
Okay?
but you can't put like
This is my derivative right here. Okay? That's what he looks like. Let's go do another one so you can see. Right here. This is saying take the derivative. This is my command. Commanding me. They're saying that my derivative needs to be with respect to x. So if I take the derivative of y to the third power, it's 3y squared, just like we would do with x's. But my primary variable is not y, it is x. So I have to put a dy dx on the end of it, right?
I have a question.
Yes, sir.
Will it ever say d over dy? And we have
No.
to do x? Okay.
No, not usually. Okay, what? Oh, okay. Okay. 3y squared dy dx. Got it?
Well, I was gonna ask the same thing.
Okay, good. All right, now let's do this one.
Listen to everybody else.
Okay, this is going to get really tricky. Okay, pay attention to this one.
This.
This thing right here is saying take the derivative with respect to x, right? This is a, hold on, this is a
That's one value. Oh, no, that product.
product.
product
This
Oh
is a
my
product.
gosh, we had
What's
all that
F?
stuff.
x. 1.
F is your x.
X, yeah.
G is the y squared. So it's like separated. Like these are your two chunks right here. Okay, so this gets really hairy. We have f prime g plus g prime f. Here we go. Ready?
F prime.
F prime, what's the
is
derivative of
1.
x? 1. G is just y squared. Plus, what's the derivative of y
Don't you
squared?
have to put dy dx?
2y.
We didn't take the derivative of y though,
Oh.
right? It's just g. Okay?
2y.
2y
X.
dy dx.
dy dx.
You need to have a dy dx. Every time you take the derivative of y, you have to have dy dx on the end.
Oh.
Okay.
Okay? And then what's f? X, right? Okay?
Whoa!
So, here we go.
Wow,
The derivative of
thank
x was 1. G was just y squared. We didn't take the derivative here, right? Okay? The next one, g prime, was 2y, but we took the derivative of y, which is 2y dx, and then x. Okay?
We would write that as.
Okay? I'm going to write it as y squared.
Where's
Simplifying. Simplifying. Y squared plus. Here's how I'm going to do this. I'm going to say 2xy dy dx.
You can't do that.
Yes, you can.
Says it.
These are all little individual chunks. I'm just going to put them in order.
I don't like it.
Oh, sorry.
dy dx is fun to say.
dy dx, yeah.
Reminds me of,
Okay, good.
X.
All right. Are we getting the hang of it kind of now?
dx.
Product rules are icky. Okay, here we go. All right, now we're going to do some stuff. This one, we have to do one little step further, but we're going to do all of this together. Okay? One little step further. Ready for this? Okay, they want us to find dy dx. Shh. find dy dx, and we're going to do the derivative of this thing. Okay, you see all my individual chunks.
Yes.
1, 2, 3, 4,
Let's
5.
add the 4.
I declare a
Okay,
thumb.
do we have any product rules?
No.
No, so this is going to be all right. Okay, so let's find the derivative of y to the third power.
3y squared dy dx.
Yep, and we need to do y dx because that is the derivative of y is dy dx. Okay, plus
2y dy dx.
2y dy dx. Okay, minus
5 dy dx.
5 dy dx. Okay, now this one,
Minus 2x.
minus 2x. Now, here you go. Listen to this. Ready? Technically, when we take the derivative of x, hold on. When we take the derivative of x, this would technically be dx dx. But what happens when you take dx dx?
Cross out. Whoa.
They cross out, right? So that's why you don't have to have dx dx on the end of each x, because dx dx cancels out. Does that make sense? Okay.
Yes.
So you technically do the same thing to x as you do to y, but since that's the variable that I'm taking the derivative with respect to, dx dx just cancels out. All right. What's the derivative of? Here we go.
Zero.
Equals derivative of -4 is
0.
0. Okay, one little baby step further, okay? One little baby step further. They want us to find dy dx, which means get dy dx solved for, right?
Oh,
So out of my terms, what?
Is y dy dx the same as just dy dx? Or no?
No.
Y dy dx, those are two separate pieces.
Yeah.
Like those two are like two
I
separate
have a
terms.
question before we get into
It's like those two things are being multiplied together. What?
If they, like, we did 3y squared plus 2y plus 5y minus 2x, can you do plus 7x?
Yes.
Can you, or plus
So
5,
can
7y?
you
do-
You
Mhm.
can combine them?
Yes.
Okay.
Yes. But
Can you divide dy dx by dy dx to get it to go away?
no. Here's what we're gonna do. Ready?
Wait, so if you had y squared.
Will you just
dy
let me show you what to do?
Yeah.
Can we
1,
add
2,
over 2x?
3, 4 pieces, right?
Oh,
These first three involve a dy dx.
it's a complex trinomial.
No, we're gonna add
Let's
2x.
eat it.
No, we're not gonna do anything hard.
I don't want
No,
that.
this is not hard. Add the 2x to the other side. Why? Because he's the only one that doesn't have dy dx on him, right?
Yeah.
Okay, now we have equals 2x, all right? Okay, you gotta pay attention, otherwise you're gonna miss a step. Ready? All three of these have a dy dx, so I'm going to pull a dy dx out in the front and write what's left over, right? I'm gonna take a dy dx out of each thing, which is 3y squared
Plus 2y.
plus 2y minus 5. Do you see where I get that?
Yep.
I take the dy dx and I like pull them all out in the front, right?
See?
Okay.
So you're
Complex trinomial.
You're
No,
basically
we don't want it.
dividing by
We don't want
dy
it.
dx.
We don't want it. Okay. No,
And
kind
then
of.
remove
Okay.
That's
Do
negative
you see
15.
where I get to this point?
-5.
But you. So you
Okay,
can't
just
divide
wait a
by
second.
dy
Just wait a second. You're getting ahead of me. Okay, this is dy dx times this thing. I want dy dx by itself.
So divide by that.
So I'm going to divide this thing over to the other side. dy over dx is equal to
2x.
2x over 3y squared plus 2y minus 5.
So
That is dy dx.
Is that your derivative?
That is your derivative, okay? Now, let's say they said, this is what my derivative is. That's the derivative. Let's say they said at the particular point, I don't know, 1, -3. I want to know what the derivative or the slope is at 1, -3 in particular, which is the slope of that line, right?
Plug her in.
I would plug 1 and, normally we just plug the 1 in because we don't have a y, but here we have an x and a y in there, right? So I would plug 1 and -3 in to find the slope of that tangent line or the derivative. Fancy? Okay?
Well,
Good? This is not that bad. This is not that bad. Go to the back side.
Hold on. Hey, we're not done yet. Hey.
Nope, go to the back. Example 4. What?
So you plugged in 1 and -3, right?
And that would give you a slope of the line.
You don't plug that into the left side of it, right?
No, because that's your that's what the derivative is. Yeah.
Okay.
Yeah. Okay. All right. We're gonna do that same thing to example 4. We're gonna find the derivative, but we're actually gonna plug the points in and solve and make the equation. Okay. So find the slope of the tangent line, which is saying the derivative, but we have a particular point to plug in for x and y. So this is x, this is y. We have to find the derivative. The square roots actually end up making it nicer than what you think. Okay. So here we go. We were finding the derivative of this thing. I'm going to rewrite him. X squared plus 4y squared. So that way I can put the derivative right below it. Okay, that's our original. And we're going to find the derivative. Okay, here we go. Piece by piece. There's 3 terms. Derivative of x squared. 2x. Technically dx dx, but that cancels off, right? All right, the derivative of 4y squared is
8y dy over dx.
8y, but we need dy dx. Okay, equals 0. Okay, now
Wait,
how do
so
I get?
That's the derivative of the equation.
That's the derivative. This is the deriv. Okay, we're gonna solve for dy dx because dy dx, like dy dx is the derivative solved for. It's like your y when you're trying to like write an equation out, right? So like you want to get y by itself to solve it, right?
-2x divided by 8y.
So I'm gonna subtract the 2x over. Minus 2x minus 2x. Okay, he's gone. Okay, so dy. I'm not gonna skip any steps. You guys can skip steps if you want to. Like some of you guys can do this in your head. Equals negative 2x. I'm gonna divide by 8y, right?
Yep.
Divide the 8y over, right? Okay, so if I simplify, dy dx, which is my derivative simplified, is negative x over 4y.
The baby, is that what he's doing?
Oh.
Negative x over 4y, yeah?
Why? He's like that.
Yeah.
Got it? If I reduce the 2 and the 8, this is my derivative, okay? So, this is what I want. I want at the point particularly,
Oh,
the square root of 2, comma, negative 1 over the square root of 2. Okay, that's a really ugly point, but that's what I'm going to use, okay? So, square root of 2, negative 1 over square root of 2. All right, so I'm going to plug those in. Negative square root of 2 goes on the top. 4 times negative 1 over the square root of 2. Okay? All right, this is actually going to come out not so bad. All right? Let's do the bottom part first. Okay, so I've got negative square root of 2 on the top. On the bottom, this is like 4 over 1,
4
right?
over the square root of 2, basically.
Yeah, right?
Negative 4 over the square root of 2.
Over 1. Okay, so this is negative 4 over the square root of 2. I multiplied the 4 and the 1 and the square root of 2 and the 1, right? Negative 4 over the square root of 2, okay? What is this as a fraction on top?
Negative 2 over 1.
Negative square root of 2 over 1, right? I'm going to keep flip it to the top, right? So I'm going to multiply by the square root of 2 over negative 4. Got it? What's the square root of 2 times the square root of 2?
Negative 2.
This would be negative 2 and over negative 4, which is
2.
1/2, or 1
1 half, yeah.
1/2. Okay, what is that?
That's
the slope.
That's the slope of my tangent line. So the m would be 1/2, right? So let's look at this line right here. This is 2, this is the point that we just found, right? This guy's m is 1/2, right? Now let's say instead they asked just for the slope, so we're done now. Let's say they ask for the equation of the tangent line. We now have 1/2 x plus b, right? Then we would plug this back in to find the b, to find the entire entire equation. This is the equation. We're not going to because it's square roots and stuff. That's the equation of the tangent line. Here is just the slope of the tangent line, or the derivative, right? Okay?
So when you
Does that
went-
make sense?
When you went from that, right there, the negative square root of 2 over negative 4 over the square root of 2, what did you do there?
You keep flip. You know what I'm talking about? You keep flip. You are taking a fraction and you're dividing by a fraction, which means you're multiplying by the reciprocal.
Okay.
You keep flip, right?
You didn't draw an arrow.
That would have been nice to know.
Yeah,
You
you
can
can.
do
Not
that.
actually done with 1 through
Right?
I've been doing it some other way. And it's
I don't know
not
why you
fun.
do it that way. Okay? All right, let's do one more and then we'll be
I've
done.
been doing it right, but I just
But we're not gonna do example 6. We're not gonna find the second derivative. Let's do example 5 and then we'll be done.
Is it the same as
Okay, this one's a little bit more complicated.
Oh my goodness.
All right. And you tell me, like this is technically a product right here, right? So we would have to use the product rule. We can, if we want to, like multiply this through. We're still gonna have to do a product rule, but it might be a little bit easier. Can we do that
Why do you have to do product rule?
if we distribute it through?
Oh, because
show
you're
you.
multiplying the x by the y.
Yep. So that, if we multiply it through, would end up looking like that, plus x squared y squared equals y squared. In which case, we still have a product here. So regardless, we're going to have to do a product rule. But the product rule might be a little bit more simplified if we just, like, distribute it through, okay? So we have 3 terms here. We've got this term, this term, this term, and this is going to end up being a product rule, right? Okay, so I'm going to make this really nice and big. All right, let's do the derivative of x to the 4th. I'm going to put them all the way over here. Yeah? 4x to the 3rd? Okay, now let's do our product rule. So I've got plus f prime g plus g prime f. I'm going to do all my parentheses.
Why did you?
Okay, equals. This is my product rule area right here.
What's that?
Why did you kick out x to the fourth already?
Because that you just do the power
I just
rule.
took the derivative, the power rule for x to the fourth. The derivative of x to the fourth is 4x cubed. Yeah?
No, Luke, I don't want your freaking answers.
Okay, equals. Let's save our product rule for the end. What's the derivative of y squared?
2y dy dx.
2y dy dx. Got it. Okay. All right. Now let's do our product rule. F is x squared. G is y squared. Got it?
Yep.
Okay. So let's do f prime. What's the
2x.
derivative of x squared? 2x, and then we just leave the y squared. We don't need a y dy dx because we didn't take the derivative of y, right?
Yep.
Okay. Now g prime.
2y dy dx.
2y dy dx. Okay. And then f is just
X squared.
x squared. All right. Now let's put
Wait,
all our stuff
question.
together. Yes, sir.
Can we combine? Can we make it 2x or 2x squared y dy dx or not?
It's the
Yes,
same
that's
thing.
what I'm going to do. That's what I'm going to do right now.
You're just moving.
So 4x to the third, that's my first term. I'm just going to leave him like that. Plus, this guy is 2xy squared. I'm just going to get rid of some parentheses. Plus, this right here Marcus just said, can we make him 2x squared y dy dx? Like, in other words, can you move this x squared over here? Sure. Why not? Like, they're all multiplied together. Okay, equals 2y dy dx.
Why didn't you just?
What?
Could you just have divided the 2y dy dx off and made the other side 1?
Uh-uh.
Booby.
I think we should divide by 2.
Divide by 2. Yeah, I was just thinking the same thing.
Yeah, you can. Sure.
Divide by 2 and that gives.
So this is 2, this is 1, this is 1, this is 1. Sure.
Is Emma here?
We can do that. No,
No.
she's gone today for a doctor's appointment or something.
Yep.
Yeah. All right. So solving for dy dx, right? Okay. So I have how many terms up here? How many pieces are there?
4.
4. 1, 2, 3, 4. Of those, 2 of them have a dy dx. We have to get those on the same side and the others on the other side, right? So what would you like to do?
Subtract 2x squared y dy dx.
I'm going to move this guy over here. So what's going to happen is he's going to subtract x squared y dy dx, right?
Yeah, there's no 2's.
Yeah, the 2 we got rid of. So this guy is now over here and he's minus, right? Because he's like on that side.
It should just be x squared.
Okay?
2x
All right.
to the third.
So 2x to the third plus xy squared equals, if I pull the dy dx out, okay, again, you guys can do this probably without having to write this middle step down. This is just y minus x squared y, right? I took like this minus this and I pulled the dy dx out,
Why?
right? I
'Cause
pulled
you
the
want
dy dx out
dy
front.
dx
Why
left.
don't you just subtract the y and the dy and the dx off?
What are you talking about?
Like just make it negative x.
I don't know what
Because
you're
it's the
saying.
same thing.
Sure.
What?
Sure.
You can't say sure.
I don't know.
I don't
Now I'm
know.
going to divide this over. So I'm going to divide, and like my final answer is going to be like this. This is my final answer for my derivative because I divided it over.
Yes.
Yeah? That's what he will look like. Got it?
What?
No.
And now
So
we're finding
messy.
slope.
So messy. Okay? Find the tangent line. So we're not just finding the slope, we're finding the whole darn thing.
Okay, plus 0.
Mm.
Is-
What?
Your slope is 0. I
No,
can
it's not.
s-
No,
or
it's not.
Your B is 0. I can see that.
Your B is
Oh, no,
not
B-
0. Your B is not 0. Your B is like not 0. This guy right here, he has a slope of positive something, and he's maybe going to intersect it. I don't think he's going to
No, he's
intersect
not
the negative
gonna
one either.
intersect it.
I don't think so.
We have to.
Uh-huh. Okay. All right. So
I have $1.
here's the ooey gooey part. Ready? Oh,
I have a
heavens.
$15 gift card to Taco Bell.
No, this actually simplifies not as bad as you think it might. Okay, so let's just, there's my derivative. We have to plug some stuff in, right? We're plugging the square root of 2 over 2.
We have to advocate for Emma. She'd be screaming.
To the third. I know, that's why I'm glad she's not here. Sorry, Emma, I'm glad you're not here.
Marky's watching
She's
TikTok.
not gonna watch.
Okay,
this
there you
video.
go. There's that. I'm plugging square root of 2 over 2 in. Square root of 2 over 2 minus square root of 2 over 2 squared times the square root of 2 over 2.
This is terrible. What are we gonna use this for?
You know, I don't know. How how do we want to do this? How do we want to do this?
I think it over so many cubes right now.
How do we want to do this? How?
You don't want to do that.
Alright, we got it all plugged in, ready to go?
If you find the square root of 2 over 2 to the third power, you already know that's the same on the top and the bottom.
Holy
'Cause
moly,
that's how
I'm glad I
multiplied
wasn't
together,
paying
you basically
attention for
put it
this
to the
one.
third power.
Yeah.
Okay?
So you can just plug that into a calculator and that solve 4 things.
I got my
Possibly.
homework done.
Possibly. That's
Alright,
exactly
ready?
how that
We
works.
got a little bit of simplifying left. Yeah. Oh, we gotta get going. Here we go. Let's go.
I did 1 and 3.
Right here. Take a look at this
Yeah,
baby
right.
right here.
Well,
Let's do
yeah, I got
third.
No. Take a look at this. We have the square root of 2 over 2 squared times another square root of 2 over 2.
Yeah,
Cube.
make it.
I'm gonna get rid of these and I'm gonna put a third right there, right? It's the same thing. There's 3 of them, right?
Yeah.
Okay? So now, ready for this?
Yep.
What is 2 square root of 2 over 2 plus 1 of those?
3 of them.
This is 3 of them, right? 3 square root of 2 over 2 cubes, right?
Oh my god.
Because there's 2 of them here and there's 1 of them
No,
here, right?
That's genius.
That was genius. Boom. Okay, the bottom is not
It's
so
just
genius.
the middle thing. No, it's combined. Just kidding.
Okay. All right, let's go ahead and solve this one out because they don't combine very nicely. What's the square root of 2 over 2 squared?
Oh god.
What's the square root of 2 squared?
Can you do the same thing?
2 over 4.
2 over 4, right? This is 1/2. So this is 1 of these minus
1/2.
1/2 of those, which is
1/2.
1/2.
ugh, Boo.
But where does the other one go?
This way. 1/2 of those, right? The square root of 2 over 2.
Yeah.
Wait, what?
Okay.
1/2.
But then there's
This
another
guy
one.
comes out to be 1/2, and this is 1, right? 1 minus 1/2 of those.
But there's another one.
What is going
Just
on?
wait a second.
So negative 1/2. So that would just be negative.
What?
It'd
No,
be
it'd be
negative
positive.
1/2.
Because this is 1. There's
Yeah,
1.
but what happened to the other one?
Oh, yeah. Yeah, gotcha.
What happened to the other one?
The other
Square
one.
root of 2 over 2 squared times the square root of 2 over 2 on the bottom.
Okay, alright, back up.
Okay.
Okay, the square root of 2 over 2, we squared that, and that
Yeah.
was 2 over 4,
Yeah, I got that.
which is 1/2, right? So this is 1 square root of 2 over 2 minus
Oh, and
1/2
then 1/2
square root
times
of
the-
2 over 2.
Ah, gotcha.
Okay, which is 1/2 square root of 2 over 2. Got it?
Yep.
Okay, so I'm going to finish this bottom part out here. 1/2 times the square root of 2 over 2 is the square root of 2 over 4, right? Yes? Sure?
Square root of 2 over. Yes.
Yes?
Square root of
Okay.
2 over 4.
Alright. Now what shall we do? Do you know what the square root of 2 cubed is?
know nothing then?
Drop that bubble.
2 square roots of 2.
2 square roots of 2. The square root of 2 square, or the square root of 2 to the third power is 2 square roots of 2, right? What's the 2 on the bottom cubed?
8.
8. Okay, we're getting closer. We're getting closer.
Multiply the 3 on the top. So,
So
6,
this is 3 over 1.
6 square roots of 2 over
6
8.
square roots of 2 over 8. On the bottom, square root of 2 over 4. I know that 6 and 8 is not reduced, but we'll do it later. Okay, now what?
Whatever you did the.
Whatever we did before.
flip
Where did you
over.
get 6 from?
4 over the square root of 2. We multiply by 3. 3 and 2.
4
Okay.
over the square root of 2. So that would be
Blah, blah, blah.
24
Okay.
square roots of 2.
No.
over-
We're going to get rid of the square root of 2's. We're going to reduce the 4 and the 8 to be 1 and 2, right?
So 6.
The final answer is
2. 1/3. Or 3.
3. Go back. 3, right?
That's
Three?
a really
6
ugly way to
times
say
1
it.
over 2
3.
is 3.
Yeah.
I beg to differ. There is no way.
There is
That's the
such a
slope
way.
now. We're not even done.
That is such a way.
Wait!
So, what does 3 mean?
That's your slope.
That's the slope of this line. So we have y equals 3x plus b. And we're going to run out of time and I don't want to plug it back in. So we're not going to find b.
Thank goodness.
Okay,
absolute torture. I
But
have
that's
no
what they
idea.
wanted us to do, is find b.
This
Holy,
is why.
holy madness. Look
We
at
need
that.
this, dude.
Implicits. Implicits. All right. What a mess. What a mess. Yes, ma'am.
On these two, do I do it like
There's no way that
this,
does
but
not-
then I solve for that?
So, this part, yep, you're going to have to do, so this is going to be a product rule.
I just heard
This is
that
going to be a
one
product
shit.
rule.
So do it like this, but then when I get here, solve it.
Now, when you go to do this product rule, the 2 and the x go together. Not like that. That's your whole F.
Do what?
This goes together.
Yeah.
So like when you take this,
You don't
when you do
have
F
to
prime,
find
it
it.
just
Find
All we have to do is
dy
find the
dx
slope.
by differentiation of negative
Yeah.
1 half.
The 2 doesn't go with the x.
Negative
What?
1/2.
The 2x.
See,
Oh, yes. I'm reading it backwards, so I think the 2 goes with the, yeah. Right.
Is this the time of year that Valerie started crying?
All right, goodbye, people watching the
I
video.
feel like she did cry over dy dx. Did Mallory cry over dy dx?
It's a good